Hello everybody, welcome back. We are talking about equivalent equations again today. We're going to do a couple of more problems just because this is kind of a confusing topic. And we are actually dealing with equivalent equations and also non-equivalent equations as well, because one of those means to be equal and one of these means to not be equal. So we are actually looking at both of these signs today, and we're going to figure out what sign goes with what problem, okay? So our first problem is going to be 2 times 3. We don't know if it's going to be equal or non-equal, so we're just going to leave that blank. And then we've got, let's do 12 divided by 2. Let's see if these are equal or non-equal. Let's see if these are equivalent or non-equivalent, okay? And just as a reminder, the word equivalent is just a fancy word for equal, and the word equation is a fancy word for problem. So basically, we're trying to figure out if these two problems are equal or not equal, okay? Let's start by doing 2 times 3. And remember to go slow and actually look at what thing you're doing here, because sometimes you're adding, sometimes you're subtracting. It just depends on which operation is showing there, so make sure you go slow and remember your strategies for these. So 2 times 3, you can easily do 2 groups of 3 in each and give us an answer. 2 times 3 is going to be 1, 2, 3, 4, 5, 6. You could also just double 3 or do skip counting by 2 3 times. Either way, whatever your method is, the answer is 6 there. Let's figure out what 12 divided by 2 is. So for division, we can do the opposite strategy for equal groups, where we don't draw 12 groups, but instead we draw 2, and we share 12 between each group and see what we get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now for this, the answer is not all of them, it's how much did each person get, because we're dividing, which is the opposite of multiplication. And here, each person got 6. So each of these sides, both are 6. So what symbol do you think we're going to put here? Equal or not equal? If you said equal, you are correct, because this problem is equal. So this is a balanced equation. This is a equivalent equation. This is good. Let's try another one and see what we get. Okay, for the next one, let's do 11 plus 13, and let's do 36 minus 19. And let's see if these are equal or not equal, okay? We're doing some adding and subtracting here. Remember, adding means to get bigger, subtracting means to take away. So let's do 11 plus 13. I always like to line up these problems whenever I'm adding or subtracting, especially if they're double digit, just because it's a lot easier to add 11 plus 13 like this than try to count up just in my head, okay? I would always recommend showing your work for this somewhere on your paper and rewriting the problem. Don't be afraid to rewrite the problem. You need to understand it in a way that works for you. This way works for me. So we always start in our ones place, and we're counting up. 1 plus 3. So 3 plus 1 more gives us 4. And then we have 1 plus 1, which equals 2. So my answer here is 24. So now we're going to come over to this side, and we're going to see if this also equals 24 or if it does not. Like I said before, when you are adding or subtracting double digits, you should definitely line them up. So for subtracting, we're going to do 36 minus 19. And for subtracting, we're taking away. So this is kind of where it can be confusing to switch back and forth between adding and subtracting and dividing and multiplying. You really have to be the boss of your own brain and tell your brain, no, we are subtracting here, which means we are taking away, we are getting smaller. So when we subtract, we ask ourselves, is there more on top or more on the floor, or are the numbers the same? In the ones place, we have a 6 minus 9. There is more on the floor, so we're gonna have to go next door and borrow. Is there anybody home? Yes. There's a 3 at home. We're going to borrow 1 from him and make him a 2. And the 1 I took from the 3, we're gonna give to the 6 and make him a 16. Now there's more on top and we can subtract. More on top, no need to stop. 9 taken away from 16. So you can actually put 16 in your head and count backwards by 9, Or you can put 9 in your head and count up to 16 to find out how much does it take to get from 9 to 16. That tells you the difference as well. That's how I like to do it. So I'm going to put 9 in my head, grab 9, and then count up to 16. 9, 10, 11, 12, 13, 14, 15, 16. And it took me 7 to get to 16. 16 minus 9 is 7. And then 2 take away 1. 2 take away 1 leaves us with 1. So this equals not 24, but 17. So here we would put the non-equal sign because these sides are not equal. They're not even close. So we're going to put the equal sign with a slash through it. And this is actually the non-equivalent sign. So we can see here that this is a non-equal problem. So the difference between an equal and a non-equal problem is that the equal problem is the same number on both sides, and the non-equivalent problem is different numbers on both sides, okay? So we know that this one is good because this means not equal. Now, the trouble comes when we have true and false questions because it can be kind of tricky if you don't slow down. So if we have a problem, let's say we have this problem, 3 times 7 equals, let's do 42 minus 21, okay? We're going to have to figure this problem out, and we're going to have to say, is this true or is this false? So let's figure out, is this true or false? Let's solve, we need to solve both sides, and then we'll see if this is an equal sign or if this should be a non-equal sign. Okay, 3 times 7, I'm going to solve this by doing 3 groups, 3 equal groups of 7, and remember we're multiplying, so we are getting bigger. I'm going to put 7 in each group. So I've got 7 here, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And now over here I've got 42, take away 21. 42 minus 21. We're going to start in the ones place. More on top, no need to stop. 2 minus 1 is 1. Same thing, more on top, no need to stop. 4 is bigger than 2. 4 take away 2 is 2. So my answer here is 21. So this has an equal sign. Is 21 equal to 21? Yes. So this would be true. Okay? Let's look at this next problem where we have 48 divided by 8 equals 12 minus 8. And let's do a not equal sign here. Okay, so this is saying that these two are not equal. They can't be equal. So we're trying to figure out, is this true or false? Let's start out by solving 48 divided by 8. For this, we are sharing, so I'm going to do the opposite strategy of what I did up here for multiplying. I'm still going to do groups, but I'm going to draw not 48 groups, but 8 groups. And we're going to split up 48 between the 8 groups and see what we get. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So my last dot ended on this, which is perfect. So it looks like each person here is going to be getting 1, 2, 3, 4, 5, 6. So this would equal 6. And then we've got 12 take away 8. And if we write this like this, we're going to have to borrow and make that into 12. So either way, it's going to be 12 minus 8. Put 8 in your head, count up to 12. 8, 9, 10, 11, 12. Gives me 4. So this says that 4 and 6 are not equal. Are these numbers different? Yes. So this would also be true, okay? Because these are not equal to each other. Now, what if we have a problem that looks like this? 20 divided by 2 does not equal 5 times 2, okay? So let's do 20 divided by 2. We're going to draw 2 groups and split 20 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It looks like each person here got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and this actually checks out because 10 times 2 would equal 20. So we know that that's true. Now let's figure out what 5 times 2 is. If I do 5 2 times, 5 plus 5, or I could skip count by 2 5 times, 2, 4, 6, 8, 10. This side also equals 10. So we've got 10 and 10. So you might think that this would be true, but you've got to look at the sign. The sign says not equal. For this to be true, and it has a not equal sign, both sides would have to be different. So this is actually false because this should be an equal sign. So if it has the wrong sign, it's going to be false. You've got to really stop and slow your brain down and think on this, because if you rush through it, you're going to make careless mistakes and get them wrong. I promise you. It happens every year when I teach this. So make sure you go slow. Make sure you look at the signs before you click true or false on your answer choices. I hope this video helped explain some things. Good luck, guys.